Hi students, today we are going to discuss grade 11 NCERT syllabus. Welcome to AstraDex. In 11th standard, we have totally 9 lessons. In that, today we are going to discuss an organic chemistry part and 2 lessons will be in organic chemistry. 1, some basic concepts, and 2, hydrocarbons. And today we are going to discuss the lesson chapter 8, organic chemistry, some basic principles and techniques. So this lesson contains the basics for organic chemistry. Without knowing the basics, we can't learn the organic chemistry, and even in grade 12 you feel difficult if you fail to read this lesson. So in today's class we are going to discuss about the fundamental concepts in organic reaction mechanisms. So at the end of the session you will come to know what is this organic reaction mechanism, what are the types of the fission will take place, what is meant by substrate, what is meant by addendum or attacking agent, and what is meant by intermediate, and what is electrophile, nucleophile, carbocation, carbanion, free radical, etc. So coming to the first introduction to organic reaction mechanism. Normally if we write an equation, how will you write the equation? We write a left hand side and right hand side. So in a balanced chemical reaction, you can see the left hand side means reactant and right hand side means the product. And a symbol plus is being introduced between the two reactant on the left as well as on the right hand side also. We can use the plus symbol by means 2 or more products is formed. As a general, we can say left and right. In organic chemistry also, a reaction will have a left and right. But coming to the left hand side, in organic reactions, the new term we are going to use here is, instead of a reactant, substrate. And intermediate will be formed. After the intermediate, the product will be the last stage. What is meant by substrate? What is meant by attacking agent? And what is meant by intermediate? Let me go and we'll discuss one by one. You all know very well organic compounds. Organic compound means the compound which can combine carbon with some other element. It may be an hydrogen, oxygen, nitrogen, sulfur, etc. So mainly organic compound in sense the main element is carbon. And you know the special property by which the carbon has is catenation property and tetravalency. So before moving to the, let me just recall what is the symbol of a carbon? C. Atomic number 6. Electronic configuration 2, 4. So it in outermost shell it has 4 electrons. It may give or it may gain. But here the 2 cases will not be possible. That is C4 plus and C4 minus will not take place. So the third case is nothing but the sharing. That's why the carbon compounds or the organic compounds which is formed by a bond is called as a covalent bond. I hope you remember the covalent bond which you have studied in grade 10. What is covalent bond? Mutual sharing of electrons is called as a covalent bond. Once again I am repeating, mutual sharing of electron between the 2 atoms leads to form a covalent bond. Because every organic reactions involves bond breaking and a bond formation. This is a simple question often will be asked by a teacher. What is chemical reaction? You will be answering a substance which is converted to a new substance. That means a chemical reaction has taken place. Like that you will answer. So if I take the organic compound, initially the bond which has been present, once a reaction has been taken place, the initially bond which is present that will breaks off and a new bond will be formed. That's why we say breaking of a old bond and formation of a new bond leads to undergo the reaction. So every organic reaction involves a bond breaking and bond formation. So understanding, so that's why it has been highlighted here, bond breaking and bond formation. Understanding the mechanism means understanding the step-by-step pathway from the reactant to the product. So the topic itself is very clear that mechanism in sense the detailed step, okay, how a reactant is converted to the product. In a stoichiometric equation, you can simply see only the reactant and which leads to form a product. But this mechanism will help in what ways, or else what are the steps which has been involved to form the product. So that's why we are going to see the step-by-step pathway, how the reactant has been converted to the product. So in this, we can have a definition which is also been given in your book, a reaction mechanism. Okay, before moving to the terms, how can we define the term? Reaction mechanism means reaction mechanism in organic chemistry is a step-by-step description, okay, of how reactants are transformed into the products, detailing its electron movement, intermediate and transition states. Okay, these things will be held detailed in reaction mechanism. So far you have used the term reactant, but here in organic chemistry we are going to use the term substrate. What is called substrate? Substrate is nothing but, it is also a reactant only, but we are giving to the name for the organic compound who is going to form the new bond. Okay, so organic compound that undergoes a reaction. In a reaction, the left hand side is again a reactant. In that reactant, if two or more reactants are present, means in that one is going to act as a substrate. The organic compound that undergoes a reaction. And the other one, the one which is not coming for the bond formation, no, that reactant we are going to say as an reagent or attacking agent or sometimes as addendum. Okay, so the species that attacks the substrate, no, the species which attacks the substrate, no, that we are going to say as a reagent. Okay, in simple we can say attacking agent, attack. It's going to attack the substrate. Then only the reaction will take place. As usual, bond breaks and a new bond will be formed. Intermediate. Once this attack has been taken place, there will be an intermediate will be formed, where this intermediate will not be stable for a long. It will be a short-lived and high energy species will be formed. Okay, so this is a short-lived. Soon after the intermediate has been formed, it will be converted to the product, right? So that's why we say that intermediate, if you see in a reaction, this intermediate is not being written. It's not been shown in an equation. Only the reactant side and the product side alone be written. But in mechanism only, we will give a detailed explanation about the intermediate. And product, which is well known, which is nothing but the stable final compound formed. Okay, the initial which we have taken as a substrate and the final which is going to set away as a product. So, a small definition which we said just now, mechanism describes the electronic and structural change occurring at each step, and this determines the rate. This is another rate in sense how fast or slow a reaction is. That means kinetics and selectivity of the reaction. Okay, we'll move to the next. Here we have two types of fission. What is this fission? Fission is nothing but breaking into two. Okay, covalent bond. So once when we start the organic compounds, this bond should be remembered. Covalent bond is present between the two atoms. Mutual sharing of electron leads to form a covalent bond. A bond here formed by means of two electrons. So if we are breaking the bond, there are two possibilities. One is it may undergo homolytic, that is evenly it can be breaks, or else heterolytic, uneven. So that's why here the topic has been introduced as fission of covalent bond. So a covalent bond can break in two ways depending on how the shared pair is divided between the two atoms. So this is the next case, ma'am, whether we are breaking the bond with the help of our energy, not our energy. The reagent is going to break it. Once the breaking depends on the two atoms in sense, if both are having the same electronegativity, the fission will take place homolytic. If one atom is having more electronegative than the another, then definitely it will undergo the heterolytic fission. Okay, we'll move further. So coming to the homolytic fission, so here a neat diagrammatic representation is given. Let me take a molecule AB, a compound. Okay, let me take a compound. The bond which is present between the A and B is nothing but a covalent bond. Okay, if this undergoes a homolytic means what? Same. So if the two electrons was equally shared by the two atoms, then what happens? A will takes one electron and B will takes another electron. So these two atoms will combine to form the covalent bond. So once it has undergone a reaction, what is going to happen? It is the fission will take place and each atom will take its own electron. So if an electron which has been taking one electron, that atom is taking one electron, no, that we are going to say as a radical. Here you can see by means of a homolytic fission, the bond splits to form two radicals. Okay, one on each atom, right? One electron is been present, one electron here and another electron is on the B. And another fission we said heterolytic. So this is a bond again, covalent bond. Bond splits to form a cation and anion, both electrons to one atom. You just say, we said that the two electrons which is present in a bond. If one atom is taking a pair of electron towards itself, means the another atom will find lacking. Lacking in sense, it will have positive charge. So if an atom has been taking a pair of electron towards itself, then it will possess a negative charge. So for example, carbon and a halogen. What are the halogens? We have fluorine, chlorine, bromine, iodine, right? If a carbon which has been bonded with the fluorine in sense, definitely the fission will take place here is heterolytic fission. So the fluorine will take a pair of electron towards itself and making the carbon to possess positive charge. When you see the atom which is possessing a positive charge, that means it loses, it lost. Okay, the electron has been lost, right? So here this is a diagrammatic representation. A gives B, A and B which has been bond present. No, here this bond breaks in a heterolytic manner. A pair of electron will move towards the B. So that's why A has lost, no, so it possesses a positive charge. B has taken that its own electron and also the excess electron which is being present on A, no, that's why it possesses a negative charge. Okay, I hope this will be very clear. So homolytic fission and heterolytic fission. So here, how the electron has been distributed. Homolytic, one electron each. Heterolytic, both to one atom. Species formed is in homolytic, the free radicals are formed. Whereas in heterolytic, it may be a carbocation or carbanion. It is not the case that always a carbon should possess a positive charge. Even a carbon may also form a negative charge. That's called as a carbanion. Okay, an arrow used, for homolytic fission, we have to use two half-headed arrows. I hope you are familiar with the fish hook arrow. Okay, it is called as a fish hook arrow. Half-headed arrow is called as a fish hook arrow. When you take a full curved arrow, it is for heterolytic fission. And here the medium which has been taken place is a non-polar or in gas phase. But mostly the heterolytic will take place in polar solvents. An example here, if I take the chlorine which undergoes a homolytic fission in presence of light, it will give two chlorine free radicals. Whereas the HCl, if I take it, where the hydrogen and the chlorine bond, the chlorine is having more electronegative, so it will take the shared pair of electron towards itself and it will possess a negative charge and hydrogen will possess a positive charge. So this is a simple key formula which makes you to easily understand where in case of homolytic fission, A-B bond will breaks into A radical and B radical, where heterolytic fission will gives A plus B minus. Okay. The next, carbocation, carbanion and a free radical. This is a very, very important basic which all the students should know. What is a carbocation? Please split up the word carbon possessing positive charge. That means carbocation. Cation means what? Plus. Carbanion. Anion means what? Negative. Okay, so if a carbon contains positive charge, it is called as a carbocation. And sometimes in old names we used to say as a carbonium ion. Carbanion means carbon which is possessing negative charge. And free radical, as usually said, the carbon which has been having its unpaired electron. Okay, with the unpaired electron. That is called as a carbon free radical. Carbon free radical we can say. So without knowing this concept, if the students goes to grade 12, they find very difficult in organic chemistry. Okay, so this is very, very important. Now I will make clear what is this carbocation, carbanion and free radical. R. When you see the R in organic chemistry, it means it alkyl group. Okay, so please remember it. Right, carbon with a positive charge. Carbon with a positive charge is called as a carbocation. And here 3 bonds will be present, which is because it has been lost one electron, no? So the hybridization will be sp2 hybridized. We will discuss this hybridization in detail in 11th standard. Then only it will be helpful for 12th standard. Okay. And the geometry is nothing but planar geometry. And here one empty p orbital will be present. Okay. And coming to the stability. So this is nothing but tertiary, secondary, primary and methyl. And most of you are very confused. What is this primary, secondary and tertiary means? A carbon which is possessing positive charge, when it is attached with only one carbon atom, it is called as a primary. A carbon possessing positive charge which is attached with 2 carbon atom is said to be as a secondary. If a carbon possessing positive charge is attached with 3 carbon atom is said to be as a tertiary. Okay. And here methyl free radical means CH3 plus. Okay. So tertiary, secondary and primary. So in upcoming classes we are going to detail this structure. Carbanion, coming to carbon which is having the negative charge. Here 3 bonds and 1 lone pair will be present. Okay, because it has been gained 1 electron, no? So it will be having sp3 hybridized, and geometry is a pyramidal geometry. And the stability, coming to the stability, it is just opposite to the carbocation. If I am taking the carbocation, it is 3 degree will be the most stable. Okay, 3 degree, 2 degree, 1 degree and methyl. Just you make a reverse, and for a carbanion, it is methyl will be having the greater than 1 degree, then 2 degree and 3 degree. Okay, so if you read carbocation, the carbanion will be very simple. Coming to the free radical. So carbon with an unpaired electron. Okay, this is also having sp2 hybridized and planar structure, and this is formed only by homolytic fission. Okay, and the stability, coming to the stability, this carbocation and the free radical will be having the same order. 3 degree, 2 degree, 1 degree and methyl. So methyl carbocation, methyl carbanion, methyl free radical. That means methyl radical. So that means CH3 only if it has positive, if it has a negative, or if it has 1 unpaired electron. We can say in 3 names like this. So here one tips for you. Carbocation stability increases with the more alkyl groups. Okay, when you see that alkyl group has been number increased, we said no, C, when it is attached with 1C, 2C and 3C, if it has been increasing, the stability will also increases. But carbanion stability is exactly opposite to the electron withdrawing group, okay, which stabilizes. Free radical or electrically neutral, but highly reactive due to the unpaired electron seeking a partner. Okay, correct. So now we are moving to the very important topic, nucleophile and electrophiles. So what is a nucleophile? With the word, again you divide into 2. Nucleo means nucleus, phile means loving. In chemistry we say nucleus, phile means loving. Okay, nucleus loving. And electrophile means, electro means electron, phile means loving, electron loving. So we will define it and we will use this term in future. Okay, that means in upcoming classes we'll be using. So now you just try to know what is this term and what are the examples we have. So species that donates an electron pair to the electron deficient center is called as a nucleophile. Nucleus loving, we say. Nucleus loving, what is the charge of the nucleus? Positive. Who will love the positive? Negative sign. That means an electron rich. A species which has been having electron rich will be seem to have a negative charge. Okay, so that's why you can see these examples. Here the oxygen which has been having the negative, which is having pair of electron to donate. So always this will attack electrophiles. Okay, so here some of an examples. Neutral nucleophile is there, anionic is there. So water, ammonia, ROH, alcohol, amine, these are all the examples for the neutral nucleophiles. So what is this? We are also having the definition in our book. A reagent that brings an electron pair to the reactive site, okay, is called as a nucleophile. A reagent. We said no reagent. Substrate we have defined, the one which is going to form a new carbon bond. Whereas another compound which is present in that reactant side, no, that is we are going to say as a reagent. So that may be a nucleophile or an electrophile, right? So a reagent that brings an electron pair to the reactive site is called as a nucleophile. And what about the electrophile? Species that accepts an electron pair from an electron-rich center always attacks a nucleophile. Just its opposite to the electrophile. Okay. So coming to the electrophile, a reagent that takes away an electron pair from the reactive site is called as an electrophile. So some examples are H+, Cl+, NO2+, R+. And for neutral examples, we have BF3, aluminium chloride, AlCl3, SO3 example. Okay, these are the examples for the neutral. And for polar bonds also, RX, alkyl halide, and aldehydes all will comes under this electrophile. So for easy to remember or in memory, you can keep nucleus loving means electron rich, okay, which donates the electron. Electron loving means which is poor, which is nothing but electron acceptor. Okay, please differentiate these two words. Electron donor, who will donate the electron? The one who is having more. And who will accept the electron? Who is poor. Okay, so the nucleophile will donate and electrophile will accept. And at last, we are going to end up the session. So with the help of this curved arrow notation, you will come to know what are the arrows we have in organic reactions. Curved arrow or the language of the organic mechanisms. Okay, they only show precisely how electrons move during the bond breaking and bond formation. Because in chemistry, simply if you write an arrow, this means gives. If I'm using a half-headed arrow like this means a electron has been transferred. If I'm using the double-headed arrow like this means it's nothing but resonance. Okay, so we have number of arrows and we have number of topics also to be discussed. So these are the double-headed, double-headed arrow. That means the electron pair movement has been shown. Single-headed arrow, and in case of arrow starts from the electron source and points to where the electron goes. Okay, so we will discuss some of the effects, inductive effect, because in the electron movement in organic reactions, electron displacement in the covalent of bonds. Under that 4 subtopics we have inductive effect, resonance effect, hyperconjugation, and the last one is electromeric effect. Okay, these effects will be discussed in upcoming classes. Thank you, students.